Down a little bit. All right, let's go ahead and start. Welcome, everybody. There's at least one familiar face. Thanks for being here. This is I'm Guy with DataStack Academy. This is a part of a regular webinar series we're doing. On Tuesdays, we do this one on data engineering as a career path. And on Thursdays, we do one that's more technically focused with some hands-on demos. So this Thursday will be a demo on Docker. So if you're interested in that, tune in again on Thursday. Okay, so this is
really quick, if I can interject really quick, Guy. Just to let everybody know, we will be recording this, and you also will receive a recording afterwards, and we send it out through our DataStack email, not through Eventbrite. So we will make sure to get this recorded for you.
Yep, and we'll post the PDF of the slides. As I mentioned in a couple of the slides, there's some more informative links in there if you want some more details. So I'll keep you posted on that as we go through, and you can check the recording out or check the slides out after we're done if you need more details. Okay, as I said, I'm Guy with DataStack Academy. We are DataStack is a data engineering focused technical academy bootcamp, and we're here to talk to you about data engineering as a career, and also a little bit about our program. Okay, so let's get started. This first slide, one question we get a lot is, what's the difference between data engineering and data science? Because a lot of people have heard of data science, but data engineering is a newer term, and not as many people are as familiar with what that means. So this pyramid here, and this comes from a really informative blog post by Monica Rogati, which is linked in the speaker notes of the slides, gives you some idea of the breakdown between data engineering and data science. So the data engineers work on the bottom 4 sections of this pyramid, and the data scientists work on the top. So data engineering is more on the back end, collecting data, moving and storing, structuring data, exploring and transforming, aggregating and labeling, basically providing the infrastructure and preparing the data for data scientists to do what they do on the front end, which is building and training models and getting the insights that they present to decision makers and executives. So the data science has been a hot term in the last few years. And one thing that a lot of companies are realizing is that as they've been putting more time and energy into data science, is that there's a significant data infrastructure required for the data scientists and analysts to do their work. And that building that infrastructure is where the data engineers come in, where we come in. So let's talk a little bit more about what data engineering as a career looks like. Here's some statistics. So this is from the Birchworks survey of several hundred professionals in 2020 and 2021. So the top number here is that 81% of companies plan to hire more data engineers. This is, I would safely say, probably the hottest field in tech right now. Companies obviously are dealing with huge amounts of data, more data every day. And so having professionals to help deal with that, help, as I said, build the infrastructure for the data scientists and the analysts to get insights out of that is more important than it's ever been. So companies right now, there's a lot of attention on data engineers and hiring data engineers. You can see here the second number, average yearly salary for a data engineer is 119K, typical entry-level positions, even though you don't usually see that term posted, but typical entry-level positions are high 5 or low 6 figures. And for an architect or a manager position, data engineering salaries can go up to 200, 250K. So it's very well paid. And you can also see this number, 50% growth in 1 year during the pandemic year in number of data engineers. This is really kind of astonishing. This is something else that shows you how much focus there is and how much demand there is for these sorts of jobs. You can see the number here, 40,000 jobs posted on Indeed for data engineers. This is a really hot market for data engineers, and in terms of supply and demand, it's a really good time to be getting into data engineering. As someone with some years of data science experience, I can say that there are a lot of good opportunities there, but with a lot of the press around data science, there were have been a lot of people getting into that area. So a lot of times when you see a job posted, there might be hundreds of applicants, and that's usually not the case with data engineers because there's a lot fewer people competing for a lot of jobs. So there's a lot of demand. And this last statistic here, which says unlimited time off, I think to clarify what that typically means in practice is that most data engineer jobs are remote, and there's a lot of flexibility around working arrangements as long as you get your work done. There's a lot more flexibility, and typical data engineering positions have health benefits, 401k. There's additional compensation. So again, these positions are very highly in demand, and there's a lot of companies hiring for them right now. Okay, so you've heard of data engineers. This is something that, even though this term is newer, this is something that everyone has benefited from the work that data engineers do. Here's just a few examples of companies that use the work of data engineers very heavily. And as I'll talk about a little bit later in this presentation, data engineers tend to be more on the back end, so their work isn't perhaps as forward-facing or as well known. But some of the applications that we're all used to, Microsoft, Dropbox, Netflix, these things are all very heavily dependent on the work that data engineers do. So let's go a little bit inside the data stack, or inside what data engineers do day to day, because it's not as obvious to everybody how this might work. So we use the terms front end and back end. Data engineers are more on the back end. So data engineers are collecting data, building the infrastructure to store that data, and then working with data scientists to help them make that data available and prepare their models. Data scientists on the front end are typically doing things like predicting market behaviors, that sort of thing, getting insights for their decision makers, their corporate executives. And the data engineers are the people who do the work, a lot of the work on the back end to make that possible. So as a data engineer, we're responsible, the person in an organization who's most responsible for data, an organization's data from start to finish, from ingestion to exploration. Again, as I said, building the infrastructure, we use the term ETL, extract, transform, and load. So taking raw data, transforming it into a form that's more usable. So the data engineer is the person who in an organization is the most responsible for an organization's data. And that means that as a data engineer, you're going to work with a lot of different other people. You're going to be interfacing with data scientists, you're going to be interfacing with application developers and other technical people. So an example that I think everybody is used to that will give all of us a little bit of insight, if you don't know as much about what data engineers do day to day, is the rideshare example. So if you think about Lyft and Uber and these other companies that are providing this great service, and there's a tremendous amount of data that's involved with those. There's raw data coming in all the time. There's customer data, there's driver data, there's geolocation data, there's transaction data. There's all these different forms of data coming in from different sources. And the data engineer's responsibility is to serve and maintain the infrastructure to allow that data to be useful to the application designers, to the data scientists and data analysts. And so that might involve taking that original raw data, structuring it in different ways, doing some extraction, extracting some features, doing some other transformation to make that data in a form that's easier for the data scientists and analysts to use. And so again, data engineers are the people that interface with a lot of different other roles in the organization, but it's typically more behind the scenes. So you might be interfacing with salespeople, you might be helping deploy external applications like CRM and HR. And so the work of the data engineer touches on a lot of different roles in the organization. So that brings us to the point of what we call the dark sides of data engineering, or just being realistic about what data engineering involves, because it's a great role and it's very rewarding in a lot of ways, but it's not for everybody, even though there are a lot of great opportunities right now, and we're very passionate about data engineering and getting people into data engineering. So as you can see, the top point here is that there's not a lot of glory as a data engineer. As I said before, data scientists is a role that there's been a lot of attention to in recent years, and a lot of people are more familiar with that. But data engineers are a role that term hasn't been around as long. People aren't as clear what that means. So as a data engineer, you're typically working in the background. Even though your work is tremendously important, it's not something that's as obvious to people outside of your organization or even inside of your organization. It's the kind of thing where a lot of people only know about you if something goes wrong. If you do your job well, people aren't necessarily aware that you're there, and that's part of the idea. So as data engineers, we're silent heroes, and we're also a jack of all trades and master of none, because there's a lot of skills involved in the data stack. And so even though we have to have our own specialties in those, there's a lot of things that we have to do well. Data engineers have to be very, very detail oriented, even more than a lot of other technical professionals. And so it's a job that if you have the skills, could be very rewarding, but it can also be demanding. There's also this point here that there's no entry level jobs. I think the idea there is that obviously people have to start somewhere, and there are plenty of people getting their first data engineering jobs, but the skills required, the skill stack required is big enough that it takes a lot of knowledge, a lot of technical education and training to get to that point. And we're going to talk a little bit about in this presentation, in a slide or two, about different learning paths and how you can get to the point of learning that tech stack and being prepared to be a data engineer. And the last point relates to this, which is the tools are pretty complex. As a data engineer, there's a lot of things that you have to know how to do. You're working in programming languages, you're working with different cloud services. There's just a lot of different tools in your tool stack. So it can be a little bit intimidating, but that's part of our goal, and our passion is to help people get oriented in this world of data engineering, and whatever your learning path is, to help you get started on that and to get to the point where you feel comfortable and where you can be rewarded and have access to these great opportunities. So this slide talks in more detail about the different learning paths to data engineering. There's two in particular that we're going to talk about. The first one is self-learning. This is a path that we typically recommend for people more that already have some technical training, some technical background, if you're not just starting from scratch. So the self-learning path can look different for a lot of people. There's a lot of great resources out there. One of the first things and most important with the self-learning path, or with just being a technical professional in general, is to take advantage of cloud certifications. All the major vendors provide certifications at associate and intermediate and professional levels. Those are really useful for helping frame and structure your own learning. They're also really useful for professional development in terms of getting a job, because those things help you. Having one of those certifications really helps differentiate you from a lot of the other a lot of people in the crowded field of applicants. So we definitely recommend to take advantage of those cloud certifications and to seek whatever of those are relevant to you. There's Google and the other vendors have data engineering, have cloud architecture and data engineering certifications, and either or both of those are very useful for data engineering. Another thing that we heavily recommend for anyone, and especially for data engineers, is as you start to get experience and you're starting to do projects, build a portfolio on GitHub. Anything you do, put it on GitHub, make a project for it, make it visible to the outside world, because it's employers definitely hire heavily based on GitHub. If you're being vetted for a position, it's almost a given at this point that somebody, a hiring manager or whoever's looking at you, will go to GitHub, will see what you've posted, what you've been working on. We like to say code doesn't lie, and when somebody can see what you've been working on and the contributions you've made and what your actual skills are in the real world, that really helps them make a hiring decision, and it can really, again, set you apart from a crowded field of applicants. So we definitely recommend making use of GitHub as a resource and making that a part of your learning path. Another thing is to tackle real world projects. So there's a couple examples listed here: Kaggle, DataHub.io. There's many of these sites that are data science and data engineering oriented to have free data sets. They have interactive tutorials. They make it really easy for free to go and start learning in the real world with real data sets that people are working on. So it's hard to overstate how useful and how important those resources are. There's just so many resources available now for technical education, and there's so many things that make it fun and easy. So we really recommend taking advantage of all those resources. YouTube, depending on your learning style, if you're more of a visual learner, YouTube is great. There's just so many different things. There's more of these listed in the slide notes, but for example, with learning Python programming, there's Replit, which is an in-browser development environment that you can program in Python without even having to download any software. The list of these resources is really just endless, and so we recommend whatever your path is to take advantage of those. There's also paid online programs like Udemy, DataCamp, Coursera. These are typically relatively inexpensive. You can pay by the certificate, and they're a lot more accessible in terms of cost. And there's many of these resources available. The trade-off with this is that you don't get, because they're less expensive and there's a lot more people taking the course, you don't get as much or any face time with the instructor. They're not as personalized. But again, particularly if you have some existing technical background, those resources can be a great part of your learning. So the second learning path here that we'd like to talk about, and we're passionate obviously about this at DataStack, is the bootcamp style. So these are really useful particularly for people who may not have a lot of technical background, or just anyone who is willing to make the commitment to make the time and the commitment of time and energy to do one of these boot camps. The world of tech, it changes so fast, it can be really intimidating and really difficult to try to keep up with it. And so the self-learning path can be hard to know sometimes where to put your time and energy. And the boot camps really help with that because they're very focused and very well-developed curriculum. And that's part of what you're getting with those. A big aspect of the boot camp style is the hands-on attention from an instructor. In our course, I'm the instructor full time, so it's our daily cadence is you have lecture in the morning, you have project work with others, programming in the afternoons, and so you have a lot of time hands-on with an instructor and with your cohort members to work on these projects, and that's something that's hard to replicate in a self-learning path. Another thing that boot camps provide that's really hard to overstate the importance of is career services. So that's internships, that's interfacing with companies, helping you find a job. And that's really useful too, because even if you have all the skills in the world, navigating the job market can be really intimidating. So getting some help with that is a really important part of what we provide at DataStack and what the bootcamp model in general provides. Obviously, a trade-off here is that the time and monetary cost of bootcamp is higher than self-learning or another path. And so to a large extent, it depends on what you want. But the monetary cost might be higher, but you get a lot for what you're paying for with the bootcamp. You get all that instructor time, you get career services. And so for a lot of people, it's worth it, even though bootcamps are not for everybody. And that's why we talk about more than one path here. Okay, so let's talk about the tools to learn. And we say here our opinionated stack because this is something that, again, can be difficult to navigate. So we're trying to make it easy for you and to simplify this a little bit for people who are wondering, if I'm trying to get into data engineering, what is the stack that I need to learn? So the basics here in the basics category, bash refers to Unix or Linux style command line, working at a terminal. So even in this world of amazing graphical interfaces, as a data engineer in particular, having some proficiency at a command line goes a long way. If you're a data engineer, you at some point probably will be expected to use command line tools, and it'll just help your work go a lot easier. Python is the language of data engineering. It was essentially made to do data engineering work, and it's become just completely dominant in the world of data engineering. There's other languages like Java that are also in use for data engineers, but Python is far and away the language, the programming language of data engineers. So that's where you should focus your time if you're just getting started. And the last thing listed under basics is SQL, or structured query language, which is the language of working with databases and working with data. The relational database model has been in use for many decades now, and SQL is the language that we use to interact with data, to get data from a database, make updates to it, delete data. And so SQL is another thing that we list in the basics because it's one of the foundations for working with data. So Docker and Kubernetes. So Docker, if you're not familiar, is a containerization platform. If you've ever heard of a virtual machine, containerization is a little bit similar, but there's some technical differences. So Docker makes it really easy. Containerization makes it really easy to deploy software in a standardized way across platforms. So we make a lot of use of it as data engineers. And Kubernetes is kind of like the next level of containerization in terms of containerization at scale. So when you're deploying software with thousands or tens, hundreds of thousands of container images being constantly updated, Kubernetes is the engine that allows you to manage and synchronize all those containers. Spark, Kafka, and Airflow are three different open source tools that are heavily in use in the data engineering world. Spark is a parallel data processing language. Kafka is a platform for streaming data and streaming analytics, and Airflow is a orchestration or scheduling tool that lets us schedule or orchestrate really anything, but it's commonly used by data engineers to manage and coordinate the different parts of a data engineering pipeline. So these are the things, the basics, containerization, and these open source tools. There's a lot of other tools in the data engineering world, but if you learn these 5 things, it'll take you a really long way. And the note at the bottom, as you can see, is learn these on the cloud. And we say that because cloud is not just the future of things at this point. Cloud is the way that most organizations have come to deploy software and to build their tools. We focus a lot on Google Cloud Platform and Data Stack because we think it's the best at a lot of things. One of the things is that the Google Cloud Platform provides really faithful implementations of these open source tools like Spark, Kafka, and Airflow. But when you're learning, make sure that you keep the cloud aspect of these things in mind. And again, this is why the cloud certifications are a good part of whatever your learning path is, because they make it much more easy and straightforward to learn the things that you need to become proficient at not just becoming a data engineer, but doing so with cloud tools. As this slide says, the time is now. There's a lot of reasons why there are a lot of good opportunities right now for data engineers. Companies are conscious of going through a digital transformation in a lot of ways. That the cloud transformation, even though a lot of companies have made that transformation to some extent, that transformation is still ongoing. As I said before, companies are dealing with ever larger volumes of data, and so having the professionals and the infrastructure to be able to deal with that is in huge demand right now, and that's part of why data engineers, it's a great time with a lot of opportunity for data engineers. Even people that have a lot of existing skills and a lot of technical skills are finding that they have to retool. That's partly to do with the cloud revolution, but partly just because the things move really fast in the tech world. As I said before, when we were looking at data engineering job numbers, the economics of data engineering are really favorable right now for the job market for people that are looking for a tech area to get into, because there's a tremendous amount of demand, and companies are struggling to fill these positions because unlike data science and some of the other technical areas that have gotten more focus, there's just not as many people that have the skills to do data engineering. So it's for that reason, it's a really good time to be getting into data engineering. And if you're getting into tech altogether, or if you have some tech background but you're looking to focus and you're looking to upgrade your skills, we think data engineering is a great place to focus. There's a lot of demand. There's a lot of job stability. Companies are only going to be dealing with more and more data. So getting in on this opportunity to become a data engineer is something that we fully expect to give you a great deal of career stability in a fast changing technical world. And that's why we're excited and passionate here at DataStack about technical education and data engineering specifically. So a little bit more about our program. At DataStack, we're a data engineering focused bootcamp. So our program is a 17-week, 10-chapter curriculum. We start with the basics, as we talked about on the previous slide, with command line skills, with Python, with Git and GitHub. Second chapter is databases and SQL. Then we go through all the different cloud tools. There's a chapter on Docker. There's a chapter on Spark, a chapter on Airflow. So we go very deeply into the cloud aspects of all these tools and into building real world data pipelines on the cloud. Cloud architecture is something that we focus quite a bit on in the course, because there's all these individual services and all these individual skills, but bringing those together in high performance applications, high performance pipelines is sort of a skill on its own. So that's something that we focus on quite a bit in our class. We're launching our first cohort this January. The start date is actually January 24th. So we partner with Epicodus, who is an existing programming bootcamp, and they provide a 3-week introduction to programming starting January 3rd. And then after that 3-week introduction, we start our 17-week data engineering curriculum. As I said in the previous slide, this bootcamp is available to anyone. I mean, we start from the very basics, and we don't assume any sort of technical proficiency, but it probably this is something that would be best for people, existing professionals, people that are maybe looking for a career switch. But we don't assume, again, that any level of technical skill required. So whatever your background, we're excited to have you. We teach all the skills that you need to know. And another big part of our course is the career services and the internship. So we guarantee an internship at the end of the course, and that's really big, because it's, as I said, there are a lot of opportunities for data engineers right now, but it's also intimidating whenever you're in tech, you're changing areas, or you're trying to get that first job. So our career services are an important part of what we provide. To find out more, datastack.academy is actually a URL, datastack.academy, or you can go to www.datastackacademy.com. At that website, you can get more information, more details on our curriculum. So there's a get started for free button. If you click that and sign up with your email, you can get a free preview of our curriculum. You can get the first 2 chapters of our course for free at a public GitHub repository. So that will give you some idea of more of the details of what the material looks like. Can give you more information than I could give you here in just a few minutes of the lecture. The course is 17 weeks. We guarantee an internship. Each one of those weeks, there's a hands-on project that you will do with a fellow student, and you'll post those on GitHub. So by the end of the course, you'll have a very well-developed GitHub project portfolio that'll also help you get a job. There's live lecture in the mornings and pair programming in the afternoons. So it's a lot of hands-on instruction. The weekly cadence is Monday through Thursday morning lectures, and then programming in the afternoon. And then Friday is time with the instructor available to work on your graded project for the week. So yeah, datastackacademy.academy will give you more information. You can sign up sign up to get our first 2 chapters for free. And then lastly, as I mentioned, we partner with Epicodus. So here's some details about the tuition upfront discount. There's more information available on that at our website. So as I said, we're excited to be making this opportunity available. We're excited about data engineering and about technical education. And so we hope this has given you a little bit more information about our program. You can go to datastack.academy to get even more information. And you can schedule a time with our mentor Param, who will be glad to talk to you more about the details and about your individual situation, answer questions for you. I'm available now to answer more questions if you have them. The last slide here is on getting a job with an industry-driven curriculum. And as I mentioned, we focus very heavily on Google Cloud in our course because we think it provides the best set of tools. And our curriculum is really oriented and structured around the Google Cloud services. So we teach the data engineering fundamentals, big data engineering, how to build data pipelines and orchestrate those. We focus very heavily, as I mentioned, on the cloud because that is the way software is built now, and that is where data engineers work. We also talk quite a bit about serverless programming, which is kind of the way of the future in terms of part of the big value add with cloud. Serverless referring to the paradigm of not having to deal with a lot of the details that administrators typically and developers used to deal with the details of servers and addresses and that sort of thing. There's a lot of the cloud services now handle all of those details for you, so you can just focus on building your application or building your data pipeline. And that's one of the great things about the cloud. As I mentioned, part of our service and what we provide at DataStack is not just the extremely well-developed curriculum, but the internship placement, career services, those things that give you not just the technical skills, but that help you navigate that world of getting a job, whether it's your first job in tech or whether you're maybe changing careers, changing roles in mid-career. And yeah, the last thing I'll say is, again, if you have other questions or for more information, go to datastack.academy. If you click Get Started for free, you can get the first 2 chapters of our curriculum. You can also schedule a one-to-one call with a mentor who will answer your questions, talk to you about your individual situation, and explain to you more about the course. So yeah, if you're interested, check out DataStack Academy, and that'll give you even more information. We know this is a big decision. We've all been there. You know, tech provides a lot of amazing opportunities, but it can be really intimidating. Things change so fast that it can be hard to know, you know, where to put your time and where to put your attention, especially when you're starting to learn or when you decide you're going to change fields. And so we've all been there. We know what it's like. We know what it's like trying to make that decision. And that's why we're excited and passionate about technical education and being able to help people navigate the world of tech and of tech careers. So if you have questions, feel free to reach out. If you go to our website, there's more contact information there. And one of us will be happy to answer your questions and to give you some guidance and to help you figure out what the best learning path is for you. So yeah, datastack.academy, go check it out, get some more details. Let us know if you have questions. And so that concludes the presentation portion. If anybody has questions, I'll be glad to answer them. I'll hang out for a few minutes in case we have questions. And Monteith, I see that you said your professor referred you. Which school is that? And again, we post these webinars. Okay, great. Thank you, PCC. Excellent. we've had quite a bit of interest from PCC already. So we post these webinars. The Tuesday one is always on data engineering as a career. The Thursday ones are more technical. So last week we did Google Cloud Platform for data engineering. This week we're going to do Docker for data engineering. So we'll post the videos for those and the slides. There's quite a bit more links and information in the slides if you have other questions. So there's a question of, are the internships remote? Param, do you want to answer that question?
Hello, guys. Sorry, I'm Parm. I'm one of the data stack folks. I had to do something today, so usually I'm on this webinar, but I couldn't make it today for another engagement. The internships are remote, yes. The internships would be remote. The way we're going to do the internships, there are a list of companies who are signed up to do the internships, and you can see a few of them on our website. We're signing up more. You will interview actually with about 5 or 6 of those companies, maybe more, and they interview you and they interview other students in the cohorts. And at the end, everybody ranks each other. So you can interview the company, you can rank the companies that you interviewed for, they interviewed you, and we try to match the best. So we try to match like the best match out of that. So if you ranked them at 1 and they ranked you at 1, we try to match up you guys together. Yeah, there's a whole list of companies here in Portland and actually outside of Portland. So most of the pretty much all the internships would be remote. Any other questions? Sorry to jump in last minute. Gonna start the video here so you can actually see us as well. Oh, I think I clicked on it. Too much. All right, it's us.
It's us. Good to see some familiar faces. Thanks everybody for your time and for your interest. It's great to see you all here.
Yeah. Thanks, Guy, for taking everybody through this. Sorry again, I'm usually here, but today I had to take care of something else. So I was just in the corner in the background.
And as CJ mentioned, yep, Thursday, same time, same place, will be on Docker. That one will be a little bit more hands-on. So yep, if you're interested, if you don't know anything about Docker, or if you do and want some more details, tune in on Thursday and we'll walk you through some of that.
That'd be a really good hands-on sort of, actually that webinar is going to be very hands-on. So it's a very good intro to Docker and kind of hands-on, like actually learning what Docker is about and how we use them. Guy and I will be there together and we'll run the demo. I'm actually going to be hands-on for this one, so that's going to be fun. So I think that's it.
Yep, we don't have any more questions. Yep. Oh, thanks, CJ. Yeah, if you're interested to find out more, so datastack.academy has a lot of information. CJ just posted that link that will take you to Calendly, and you can make an appointment to talk to Param one-on-one in more detail. So yeah, check out the website. If you're interested and you have questions, click the Calendly link and schedule a chat. And we're all here available to answer questions. And yep, keep checking out the webinars. There's another one on Thursday about Docker, and this will be an ongoing weekly thing for the next few weeks. So thanks, everybody.